Welcome to our deep dive, and today we're taking a look at self-driving cars. You know, that idea that we can just sit back and let the car do the driving. It's been around for a while, like science fiction stuff, but now it's becoming reality. And what we really want to do is figure out, how did we get here? You know, how did this technology go from dreams to actual cars on the road? And to help us unravel this story, we're diving into a fascinating book called Driven by Alex Davies.
Yeah, Driven is a great starting point, I think, for anyone who wants to really understand the history of self-driving cars. And, you know, what's interesting is that this whole revolution didn't actually start in Silicon Valley. The roots of this technology are kind of surprisingly tangled up with the U.S. military.
Oh, wow. Okay. I did not see that coming. So how did the military get involved in something like self-driving cars?
Well, it goes back to 2001.
Mm-hmm.
Congress passed this massive bill called the Floyd D. Spence National Defense Authorization Act. And buried in that bill was the section 220. And what it did was it basically called for the development of unmanned vehicles. You know, at the time, unmanned aircraft were already being used, but ground vehicles are a whole other challenge.
Right. Yeah, I can see how that would be way more tricky. I mean, the sky is wide open, but down here on the ground, there's so much more to run into, you know?
Exactly. And the complexity of navigating a constantly changing environment with pedestrians, with other cars, and unexpected obstacles. It was a massive hurdle.
Yeah. So how did they even begin to tackle this challenge? I mean, it couldn't have been easy.
Well, that's where DARPA comes in, the Defense Advanced Research Projects Agency. They're known for pushing the boundaries of technology.
Yeah.
And they had a leader at the time, Tony Tether, who wasn't afraid to think outside the box.
So what did he do? Did he just throw a bunch of money at the problem and hope for the best?
He actually took a pretty unique approach, a public contest with a big cash prize. Tether wanted to attract the best minds from all over, not just traditional defense contractors.
Mm-hmm.
And he decided to create a race for autonomous vehicles, something that would capture the public's imagination and really drive innovation.
A race for robot cars. That's brilliant. Where did they even hold something like that?
Well, after some debate, they landed on the Mojave Desert. It provided the wide open spaces needed for the race, but it also presented some interesting challenges.
Yeah, but the desert is a pretty unforgiving environment.
That's putting it mildly. The logistics of the race were a nightmare. You know, not only did they have to deal with the rough terrain, the extreme temperatures, but they also had to be mindful of the delicate desert ecosystem, especially.
Yeah.
The endangered desert tortoises.
Okay, hold on. Tortoises. How did tortoises become a factor in a robot car race?
Well, these tortoises are very sensitive to disturbance.
Yeah.
And the last thing DARPA wanted was to cause an ecological disaster in the middle of their high-tech event. Imagine having to navigate a course while making sure you don't accidentally run over a tortoise. That could literally pee itself to death from stress.
That's definitely a new one. So this whole tortoise situation aside, did this race actually happen?
It did. The first DARPA Grand Challenge took place in 2004.
Mm.
And it was a complete disaster.
Really? Not a single car finished?
Nope. Out of the 15 vehicles that started, the furthest any of them got was just 7 miles.
Yeah.
Some crashed, some got stuck, and some just refused to move.
Yeah.
The technology just wasn't quite there yet.
I bet that was pretty embarrassing, especially with all the media attention.
It was. But, you know, here's the thing about failure. It often leads to the most valuable lessons. The 2004 Grand Challenge highlighted the immense complexity of building a truly autonomous vehicle, and it forced the teams to rethink their approaches.
So what were some of the key takeaways from that first race? What did they learn from all those crashes and breakdowns?
Well, they realized that navigating the real world is far more challenging than they initially thought.
Right.
The robots needed better sensors, more robust algorithms, and a deeper understanding of how to deal with unexpected situations.
So it was back to the drawing board.
In a way, yes. But the teams weren't discouraged. They were determined to crack the code of self-driving. And they knew that the next Grand Challenge was just around the corner.
So the first Grand Challenge was a bust.
Right.
What happened next? Did they just give up on the whole self-driving thing?
Not at all. In fact, the 2005 Grand Challenge saw a major shift. You know, the 2004 event really exposed the limitations of the technology, but it also sparked a wave of innovation. Teams went back to their labs, analyzed the failures, and really doubled down on their efforts.
So what changed between 2004 and 2005? Was it just a matter of refining existing technology, or were there some breakthrough innovations?
There were definitely refinements, but one crucial advancement really emerged, and that was LiDAR.
LiDAR. Okay, I've heard that term before, but I'm not entirely sure what it is. Can you break it down for us?
Sure, LiDAR stands for light detection and ranging. It's basically a sensing technology that uses lasers to create a highly detailed 3D map of the surrounding environment.
Imagine a radar.
But using light instead of radio wave.
Okay, so how did LiDAR change the game for self-driving cars? It sounds pretty technical.
It was a game changer because it gave the vehicles a much more accurate and reliable way to see the world around them. Before LiDAR, a lot of teams relied on cameras and radar, which had limitations, especially in challenging conditions like dust or darkness.
So with LiDAR on board, how did the 2005 Grand Challenge play out? Was it another desert demolition derby?
Not this time. The 2005 race was a resounding success. 5 teams completed the 132-mile course, a dramatic improvement over the previous year.
Wow, so somebody actually won.
Yeah, Stanford University's team, led by Sebastian Thrun, took home the victory with their modified Volkswagen Touareg named Stanley.
Stanley, as in the Stanley Cup.
Well, not quite. This Stanley was equipped with a cutting-edge 64-beam LiDAR system, developed by a brilliant but somewhat unconventional engineer named Dave Hall. And this LiDAR gave Stanley an incredible ability to perceive its surroundings and make split-second decisions even at high speeds.
So LiDAR really was the key to unlocking the potential of self-driving technology.
It was a major turning point. The 2005 Grand Challenge proved that self-driving cars could not only function in challenging environments, but they could also compete at a high level. It shifted the conversation from, is this even possible, to how can we make this even better?
I see. So conquering the desert was a huge step forward. But the desert isn't exactly the real world. Did DARPA just keep sending these cars back into the Mojave, or did they eventually move on to something more, well, urban?
You're reading DARPA's mind. They knew that the ultimate test for self-driving cars wouldn't be in the open deserts, but in the complex and often chaotic environment of a city.
Yeah.
And so the urban challenge was born.
Okay, that sounds like a whole different level of difficulty. What exactly did the urban challenge involve? Was it just like a regular city driving test, but for robots?
It was much more complex than a simple driving test. The urban challenge held in 2007 required the vehicles to navigate a 60-mile course on a former military base that had been transformed into a mock city.
A mock city. So they built a whole fake town just for this race.
They did.
Yeah.
And they didn't skimp on the details. The course included traffic lights, intersections, merging lanes, parking lots, and even other vehicles driven by humans.
Wow, that's some serious commitment. So were the robots expected to just drive around this fake city, or did they have specific tasks to complete?
They had to follow a set of mission objectives, things like merging into traffic, navigating roundabouts, parking in designated spots, and even avoiding obstacles like stalled vehicles.
That sounds incredibly difficult. Did any of the teams manage to pull it off?
Several teams successfully completed the challenge, demonstrating that self-driving cars could, in fact, handle the complexities of urban environments, at least in this controlled setting.
This is all so fascinating. It seems like every challenge, even the failures, pushed the technology forward. But where did things go from here? Did any of these teams take their experience from the DARPA challenges and try to turn it into something, well, real?
That's where things start to shift from government-funded projects to the world of private companies and commercial ambitions. And this is where a certain tech giant enters the picture, Google.
All right, we're back, and you mentioned Google stepping onto the self-driving stage. What was their approach? Did they jump right into building robo-taxis or something?
You know, it's funny you should mention robo-taxis because that was definitely on their radar.
Yeah.
But their entry into the self-driving scene wasn't as straightforward as you might think.
Okay, I'm intrigued. What was Google's game plan then?
Well, in 2009, a small team of engineers at Google, led by Sebastian Thrun, the victor of that 2005 DARPA Grand Challenge, launched a project that they called Chauffeur. And it was a moonshot from the start.
A moonshot, huh? That sounds like classic Google. So what was their ambitious goal?
They aimed to create a fully autonomous car, capable of driving anywhere, anytime, without any human intervention. And Google's founders, Larry Page and Sergey Brin, were completely on board with this. They saw it as a chance to completely revolutionize transportation.
Yeah.
And they weren't afraid to invest heavily in the project.
So Google was going all in. But how did they even begin to tackle such a massive challenge? I mean, it's one thing to build a car that can navigate a desert or a mock city, but the real world is a whole different beast.
They knew that real-world driving was the ultimate test. So they focused on accumulating as much real-world data as possible. They equipped their cars with a suite of sensors, cameras, radar, and of course LiDAR, and they sent them out onto the streets of California.
Because they were basically letting the cars learn by doing.
Exactly. They adopted a data-driven approach, feeding the cars massive amounts of information about real-world driving scenarios and using machine learning algorithms to help them make sense of it all.
That makes sense. But didn't they also create those super detailed maps? I vaguely remember reading something about that.
You're absolutely right. They realized that even with advanced sensors, having a highly accurate map of the environment would be incredibly helpful, especially in complex urban areas. So they embarked on another ambitious project, creating high-definition 3D maps of their test areas down to the centimeter level.
Wow, that must have been a huge undertaking. Was it even worth the effort?
Oh, absolutely.
Right.
Those maps provided a crucial layer of context for the self-driving system. It's like having a cheat sheet for the road, allowing the cars to anticipate things like lane changes, upcoming intersections, even pedestrian crossings.
So Google was investing heavily in both the technology and the data needed to make self-driving a reality. But what about the other players in this space? Was anyone else trying to keep up with Google's rapid progress?
Well, there was one company that was starting to feel the heat, Uber.
Uber, the ride-hailing company. Why would they be interested in self-driving cars? Wouldn't that kind of like cannibalize their own business?
You know, that's the fascinating part. Uber's CEO at the time, Travis Kalanick, saw Google's self-driving project as an existential threat.
Yeah.
He realized that if Google could figure out how to make robo-taxis a reality, it would completely disrupt the ride-hailing industry, which Uber was dominating.
I see. It's like the classic innovator's dilemma. If you don't disrupt yourself, someone else will.
Exactly. So Kalanick decided to launch Uber's own self-driving program, and he did it with his signature aggressive style. He started poaching top engineers from other companies, including Google, and making strategic acquisitions to quickly build up his team and technology.
And wasn't that around the time that Anthony Lewandowski, who we talked about earlier, left Google and started his own self-driving truck company called Otto?
That's right. And Kalanick saw Otto as a golden opportunity. Lewandowski had a team of talented engineers, and his technology seemed like a perfect fit for Uber's ride-hailing ambitions.
So Kalanick acquired Otto, right?
He did. In 2016, Uber bought Otto for a whopping $680 million. It was a huge gamble. But Kalanick was betting that Lewandowski was the key to catching up to Google.
But didn't that acquisition lead to a major legal battle between Google and Uber? Something about stolen trade secrets?
You got a good memory, Google or Waymo. As their self-driving division was now called, accused Lewandowski of downloading thousands of confidential files before he left Google to start Otto. And these files allegedly included designs for their LiDAR system, which was a core part of their self-driving technology.
So basically corporate espionage.
That's what Waymo alleged. And it became a very messy and public legal battle that ultimately tarnished Uber's reputation and cost them a lot of money. They ended up settling with Waymo for hundreds of millions of dollars and agreed not to use any of Waymo's technology in their self-driving cars.
Wow, what a mess. So what happened to Lewandowski after all that? Did he stay at Uber?
He did for a while, but Kalanick eventually fired him amidst all the controversy. It was a dramatic fall from grace for someone who had been at the forefront of self-driving innovation.
It's a reminder that even in the world of high technology, things can get pretty complicated.
Absolutely. The race to develop self-driving cars wasn't just about technical innovation. It was also about ambition competition, and in some cases, questionable ethics.
So where do things stand today in 2025? Who's winning this self-driving race? Is it Google or Waymo, I should say?
It's still a very complex landscape. Waymo has arguably made the most progress in terms of actually deploying robo-taxis, but they've taken a very cautious and measured approach. They've launched limited services in a few cities, and they're still accumulating millions of miles of testing data.
What about Uber? Are they still in the game?
They are, but they've definitely scaled back their ambitions. They've sold off their self-driving truck division and are now focusing on partnerships with established automakers. They seem to have realized that going it alone in this space is incredibly challenging.
And what about other companies like Tesla and GM? Where do they fit in?
They're both major players in the self-driving space, but they're taking different paths. Tesla is focused on developing a system that can eventually be used in all their cars, while GM's Cruise division is more focused on robo-taxis, similar to Waymo.
So it's still a race, but the finish line seems to be further away than we initially thought.
That's a fair assessment. The early optimism that we would have fully autonomous cars everywhere by now has faded somewhat. The technical challenges are more complex than many anticipated,
Yeah.
and there are still many unanswered questions about safety regulation and the societal impact of widespread self-driving technology.
It sounds like the journey to a driverless future is going to be longer and more complicated than we initially imagined.
It will be.
Yeah.
But it's also a reminder that technological progress is rarely a straight line. There will be setbacks, there will be controversies, but the journey itself is just as important as the destination.
Well said. As we wrap up our deep dive into the world of self-driving cars, I'm left with a lingering question. If self-driving cars do become ubiquitous, how do you think our cities, our commutes, and our relationship with cars will change? What would those visionaries from the past, like Bel Geddes with his Futurama exhibit, think of how things have actually unfolded?
That's a great question.
Yeah.
And one that we'll all have to grapple with as this technology continues to evolve. The possibilities are both exciting and daunting. Self-driving cars have the potential to reshape our world in profound ways. But the path forward is still uncertain.
Thanks for joining us on this incredible journey through the history of self-driving cars. It's been a fascinating exploration of innovation, ambition, and the unexpected twists and turns that often accompany groundbreaking technological advancements. And as always, we encourage you to keep exploring, keep questioning, and keep diving deep into the world around you. Until next time.